Alrighty everybody, welcome back to Dr. James's Science Spectacular. This is the Pigpen Pond that I told you about earlier. Now for the first part of our 4-part series, the introduction. B, how are you doing today?
I'm doing quite well. It's a little misty.
Longtime viewers may remember B from our special on manatees. It's been a while, but here she is again to talk to us about this pond.
Alright, so in our Science of Water class lab, we once went to Pigpen Pond to collect water samples with a dissolved oxygen collector so that each group could do various water quality tests. I noticed that at the end of the class, when every group had their results shared by the instructor, that some of the results were inconsistent. A possible reason for this is that some groups threw their dissolved oxygen collectors off the pier and into the deeper waters of the pond, while others collected their samples from the shallow waters of the edge of the pond. We, our group, chose 4 water quality tests to run on samples from Pigpen Pond: conductivity, pH, dissolved oxygen, and phosphates. Pigpen Pond is not extremely affected by many man-made influences like highways. However, there is construction occurring nearby, which could be influencing the water quality of the pond. I chose conductivity because it is correlated to salinity levels, and a high salinity in the pond would be related to more chemicals being discharged in the pond, reducing the quality. I chose pH because it is a good indicator of the water's quality, and it is possible that water from the shallow part of the pond would be more basic due to rainfall. Also, freshwater ponds normally have a pH of 6.5 to 7, so a pH that is more basic or acidic than that might be detrimental to the organisms living in the pond. I chose dissolved oxygen because it is a good indicator of how well wildlife can be sustained in the water, because they need oxygen to survive. I also chose phosphates because high levels of this are also indicative of chemicals like fertilizer. However, some is good to have because there are organisms in the pond that need it to survive. For the location of our samples, we chose the pier of Pigpen Pond because that is where we drew our first observation about potential differences in water quality relating to depth. I hypothesized that the depth of the water in the pond would have an effect on the water's quality. I predicted that the water from deep in the middle of the pond would have a higher water quality, that more phosphates, more neutral pH, and more dissolved oxygen, and a lower conductivity than the waters from the shallow edge of the pond.
How's it going, guys? I'm Hunter, live here from the beautiful Pigpen Pond, where we experimented for our research project. Just gonna start it off real quick. Little control conditions. Control conditions were the testing of the samples that we took, the weather in which we took all of our samples, and the process in which we collected the data from each sample. The ones we tried to hold constant were the amount of water of each sample and the procedure of collecting each sample. The independent variable of our experiment, of course, was the location, and the dependent variable was each parameter of the test we chose. To test the pH, phosphates, and amount of dissolved oxygen in each sample, we used each test tube containing the samples from the deep and shallow waters that were in the 2 dissolved oxygen collectors and put them in the Smart 3 colorimeter. When we put them in the Smart 3 colorimeter, we followed the directions for the manual of the colorimeter for each test, and we were able to gain our samples. You heard it here first. This is Hunter, Pigpen Pond. We're out.
So Aaron, how were the results for Group 4?
Okay, so for Group 4 we actually found that there were a lot of differences between the shallow end and the deep end of Pigpen Pond. So we tested the pH, and the pH of the shallow end was 6.6, and in the deep end it was 6.5, which we had predicted, but we kind of expected it to be more drastic. The phosphates in the shallow area were 0.35 parts per million, and in the deep area they were 0.77 parts per million. So there was a really big difference there between the deep area and the shallow area for the phosphate level.
Alrighty, can you tell us about the dissolved oxygen levels?
Yeah, the dissolved oxygen in the shallow area, the dissolved oxygen was 6.5 parts per million, and in the deep area, it was 10.5 parts per million. So that shows that there was a lot more dissolved oxygen down in the deep middle of the pond.
Aaron, can you remind me the last part of your guys' project?
Yeah, we tested the conductivity last, and what we found was that they were pretty similar in the shallow and deep areas. In the shallow area, it was 44 microsiemens per second, and in the deep area, it was 47 microsiemens per centimeter. And this is actually really interesting because the optimum kind of range for conductivity is from 150 microsiemens to 500 microsiemens per centimeter, and this is way below that. So even though there's very little dissolved ions, it's not suitable to sustain diverse aquatic life.
Well, thank you for discussing the results today, Aaron, and glad to see that you're healthy.
Thank you.
Well, folks, catch us next time as we wrap all of this up with our final evaluation.
Group 4.
Welcome back, folks, to Dr. James's Science Spectacular. This is Tiffany. You longtime viewers may remember her from our discussion, Is Denim Better Than Corduroy? Tiffany, it's lovely to have you back.
All right, so after testing the quality of the water in Pigpen Pond, my group found that dissolved oxygen was significantly higher in the sample from the deeper portion of the pond than the shallow portion. We also found that phosphates were significantly higher in the deeper sample than the shallow sample. The pH in the deeper sample was slightly more acidic than the shallow sample, however, not significantly so. The conductivity was also very slightly higher in the deeper sample than the shallow sample. There are several potential reasons for the dissolved oxygen being higher in the deeper part of the pond than in the shallow part. The shallow edge of the pond was near growth of plants, trees, and other brush, a lot of which leaves organic materials in the lake, like dead leaves from trees. It is possible that bacteria that are consuming the organic matter in the shallow edge of the lake and thus using dissolved oxygen, leaving less than in the deep portion of the lake. For the differences in the levels of phosphate in the two depths, it is possible that the phosphates in the deeper part of the water are due to animal waste being excreted into the pond by creatures like turtles and birds. Animal waste brings phosphates into the pond water. It is also possible that the sediment at the bottom of the pond is phosphorus rich and is kicked up by fish and other animals that live in the pond, thus bringing phosphorus back into the water to become phosphate. The conductivity of the deep part of the pond versus the shallow portion differed only very slightly, but it is possible that this is also because of the soil and rocks that are part of the pond. The results of this experiment lead me to accept my hypothesis that the depth of the water in the pond would also affect the water's quality.
Now, Tiffany, could there have been any errors on this project?
Definitely. It is definitely possible that some of our results were found due to error on our part. We did not measure the depth of the area which each sample was taken from, so we have no way of knowing exactly how much more deep the sample from the deep part of the lake is in the shallow part of the sample. It is also possible that someone mishandled the equipment while testing the various measurements or missed a step due to misreading the instructions. For future experiments, I would suggest measuring the depth of the pond that the samples are going to be taken from. I would also suggest that both the depth of the water as well as the location of the water be tested for. This way, the experimenters could potentially know if the location of the water in the pond has any noticeable effect on the water's quality in addition to depth.
Thank you again, Tiffany. It's always great to have you on this show.